Hi everybody, in this video we are going to be talking about unit 11.1.3, which is products and quotients raised to powers. Guess what? Same format. We are going to be doing the discover the rule thing. We're going to look at some examples and then we are going to figure out why in the world do these rules make sense. So here we go. Expand and simplify the following. So here it says take 2a and we're raising it to the fourth power. So that's going to be 2a times 2a times 2a times 2a. And then based on what we were doing really just up here, we are going to go like this. We are going to say, well, how many 2's do I have? I've got 1, 2, 3, 4 of them, and they're all being multiplied. So it's going to be 2 to the fourth. How many a's do I have? I've also got 4 of them. And they're all just being multiplied. So I'm going to add those exponents just like what I would have done on the 2's as well. And so I'm going to have a to the fourth. So it's 2 to the fourth, a to the fourth. And again, if we were evaluating it, we would end up saying, well, what's 2 to the fourth? And that would be 16. But again, we're just figuring out the rule, so we don't have to do that. Well, how does that compare to what we started with? And like, could we figure out a rule? Well, I'm hoping you see, well, I see that there's a 4 here and a 4 here, and we started with a 4. And you may not really be able to conclude anything yet, but one thing I'd like for you to look at is, well, what's the exponent on the 2 inside the parentheses right now? The implied exponent is a 1. Same with the a, right? It's a to the first. So let's see what happens on the next one. Let's see if we can kind of conclude our rule. So the next one says, okay, take 3/4 times 3/4 times 3/4. Well, how many 3's do we have? We've got 3 of them. How many 4's do we have? We've got 3 of them. I almost said 4 of them. We've got 3 of them. So again, look at what we started with. And I want you again to think about what's the exponent on the 3 inside the parentheses? It's a 1. What's the exponent on the inside, on the 4 on inside the parentheses? It's also a 1. And so our rule can actually be, our rule here is going to be, we're going to take this 1 and the 3, and we're actually multiplying them. And we're multiplying it here, and then we're multiplying it down here too. But let me show you something else, because we didn't really give you an example of this. So what if instead we had something like this? We had like 3a squared, and we were raising that to the fourth power. So I want you to think about that. We had that one instead. So that again would mean that we would have 3a squared times 3a squared times 3a squared times 3a squared. So if that's the case, then we're looking at, okay, how many 3's do I have? 1, 2, 3, 4. And again, that's because I'm counting up the exponents, right? So I've got 3 to the fourth. And then a's, 2, 4, 6, 8. Because we're adding up those exponents because we're multiplying. Remember, that's our product rule. So that would be a to the fourth, or not a to the fourth, 8, a to the 8th. And how does that then compare? And that one really shows you like where in the world does that rule come from? And so the rule that we are going to get for a product here, again, I would highlight that. There's another one of your rules. Here's another one of your rules. We've got our product rule that says this: if all we have inside parentheses is multiplication, that means that we can take this x and we can distribute it in. It means we're going to multiply it in. So it's going to be a to the x times b to the x. It does not mean this. So like caution, this is a huge do not do this one. If you have this situation, so this is like, what if we have 3x plus y and that's raised to the third? Well, maybe I'll say the second power. So we've got a different number in there. And it's raised to the second power. That does not equal 3 squared x squared plus y squared. Remember, that's the one way back on like exponential notation. If I can even find it right here, that said we don't do x squared plus y squared. Try not to make people sick here or myself. It does not equal that. What that actually would mean is that we are saying, if it was actually squared here, it would be 3x plus y times another 3x plus y. And so you don't use your product rule here. Like you don't go, oh, I'm going to distribute the x here and here. You cannot do it there because you've got that addition sign right there. So what is this rule called? It's called a product. What is a product? A product is multiplication, right? It's the answer to a multiplication problem raised to a power rule. It doesn't say a sum raised to a power rule or a difference raised to a power rule. Here's your difference one. It says a product or a quotient, and that's division. So this one works for division too. If you have just division or like a fraction going on inside parentheses, you can take the x to the a and the x to the b. So it's going to be a to the x all over b to the x. And that is similar to something even like this. Like if we've got, let's say we've got a squared times b all over c to the third, I don't know, times d squared, something like that. And if we are taking it to the fourth power, if we've got something like that, I know all we've got in here inside the parentheses, you're checking. Do all I have is multiplication and or division? Yes. So in that case, you can take your exponent and you can distribute it to every single one of your terms. And so that would mean that we would have a to the 2 times 4 times b to the fourth, because b is like raised to the first power, right? And then it would be c to the third power times 4. And then it would be times d squared times 4. And then we would finally simplify that and say, okay, well, that's going to be a to the 8th, b to the 4th, all over c to the 12th, d to the 8th. And then we'd be done. That's as far as we can take that one. We can't simplify it anymore. Okay. So let's look at some more examples. So our next example that we are going to look at, we've got the quantity of -3x cubed y squared z, and we're raising that all to the fourth power. So again, check inside your parentheses. Do we have any addition or subtraction? Don't let that negative mess you up. There's no addition or subtraction, that's just a negative. But I do want you to think about how that's like a -1 out front. Or you can think about it being like a -3, like that, because the 3 is also inside the parentheses. So here we go. We are going to do -1, and I'm going to say to the fourth, and I'm actually going to get rid of this parentheses. We don't need that anymore, because we're going to take this 4 and we are going to distribute it to each of these. And so then we're going to get times 3 to the 4th times x to the 3 times 4 times y to the 2 times 4 times z to the 1 times 4. And now let's simplify. So -1 to the 4th is going to be +1. So we don't need to write +1. And then 3 to the 4th, I like to think, well, 3 squared is 9. And 3 squared times 3 squared is the same as 3 to the 4th, right? And this is 9 times 9, which hopefully you guys know, and that's 81. So we get 81 times x to the 12th, y to the 8th, z to the 4th. And that's our answer. That's as far as we can go. Let's try another one. So our next one is we've got 2xy all over x, and then we're raising that to the third power. All right, first look inside the parentheses and see if there's anything you can simplify, and then also verify, do we have any addition, any subtraction? Because if we do, we can't do our product. We can't do our, I'm blanking out. We can't do our power rule. So we can't do our power rule on a product or a quotient. And we don't have any addition or subtraction, so we are allowed to do our power rule. I'm going to cross off my x's because x over x reduces to 1. right? So now what that means I have is that I've got 2y raised to the third power, which is going to equal, I'm going to come back down here, which is equal to 2 to the third. Whoa, that does not look like a 3. 2 to the third times y to the third. And 2 to the third is going to give me 8, and it's going to be 8y to the third. And that's our answer. That's as far as we can go. Let's try another one. So our next one is going to be a, b, c raised to the second power all over the quantity of a, b raised to the third. So tell me, would I be allowed to cross off the a's and the b's right away? So think about that. Would I be allowed to cross off the a's and the b's? Why or why not? So the answer to that, the answer to my question is no, you can't. No, you cannot just cross them off immediately. Because why? Because follow order of operations. Order of operations says look inside your parentheses. There's nothing to simplify. Now do exponents. And that's what we're going to do here. Parentheses, exponents, and then we're going to simplify. This one, what did order of operations say? Because you might be saying, well, wait a second, we cross off the x's above. Well, what did order of operations do this time? The parentheses were around the entire thing, the numerator and the denominator. And so that one we were allowed to cross off the x's to begin with. So I just want to point that out. All right, so let's go back. All we have is multiplication in the numerator. So let's distribute that in. All we have is multiplication in the denominator. So let's distribute that one in. And we're going to get a squared, b squared, c squared all over a to the third, b to the third. And now we're ready to reduce. We can take these two off and these two off. And then, so what's left in the numerator? All I have left in the numerator is c squared. What do I have left in the denominator? I've got a to the first and b to the first. Do I need to write a to the first and b to the first? No, I can just write ab. So this is going to be c squared ab. So the other way I want to show you, just so in case you get something like this on Ed Ready, and it's going to show you both ways, what would my exponent be if I brought the a up and if I brought the b up? What would my exponent be? If I wrote ABC squared, because I can't just write ABC squared because A does not equal 1 over A. But A to some power does equal that. And it would be A to the negative 1 and B to the negative 1. So A to the negative 1 equals 1 over A. And that's one of your rules again, so don't forget that. Again, if you're like, well, crap, I don't remember that rule. How am I gonna, what's another way to think about that, Liz? Well, you can look at it like this. If we were at this stage and I said, bring all of your variables to the numerator. So if I had a squared, b squared, c squared, and it was a to the third, b to the third, bring them all up. So if I said, well, I'm gonna bring this guy up and I'm gonna bring this one up, and then we would have a to the negative first, b to the negative first, c squared. Ta-da! That's another way to do it. All right. I've got 2 more for you, and our last one has like 2 parts. I'm out of room there, so let me come back up. 2 more for you. So here's number 4, and number 5 has 2 parts. So number 4 says 4x cubed raised to the 5th power times the quantity of 2x squared, and we're raising it to the negative 4th power. All right, let's try it. First, look inside your parentheses, see if there's any addition or subtraction, and there's not. So let's go ahead and distribute this in. So distribute the 5 in, distribute the negative 4 in. Don't let the negative 4 scare you. It's just a negative. So we're going to have 4 to the 5th times x to the 15th times 2 to the negative 4 times x to the negative 8th. So at this point, if you want to, hang on, let me get rid of that line again. I don't think that's going to help. It's going to make it more confusing. So let's look at this. And one thing I'm going to do is say, let's go ahead and let's rewrite these so they have positive exponents, because I think that'll make these a little bit easier. So we're going to go 4 to the 5th times x to the 15th times 1 over 2 to the 4th. And here's another way. If you wanted to, you could just say, well, what's 15 minus 8? You could do it that way too. And you're just going to get x to the 7th. If that doesn't make sense, you can do it this way as well. And you can say times 1 over x to the 8th. All right, now let's multiply straight across. So then I'm going to go ahead and say, well, what is 4 to the 5th? 4 to the 5th is going to equal 1024. And we've got x to the 15th all over 2 to the 4th, which is going to give us 16, x to the 8th. Let's take 1024 and divide it by 16. Let's see what we get. And it goes in evenly. And we end up getting 64. And then let's take off the 8 from here, from down at the bottom, the 8 x's. We're going to take it off up here. And we're going to get x to the 7th. And that, my friends, is your final answer for that one. And by the way, there are so many different ways to do this problem. So if you're like, hey, couldn't we have done this instead? Send me your ideas or show me your ideas in class and office hours, something like that, so that I can see your ideas and just say, yeah, you can definitely do it that way too. Because there is lots more ways to do it than just that. All right. I think I'm going to try to make use of this space over here. Let's see. All right, well, here's our expression. Our expression is 24 x to the 8th y squared. And that's going to be all over the quantity of 2x to the 3rd y, and we're squaring that quantity. And we are going to be using values of x equals 3 and y equals -2. So here's part A. Part A says simplify, then evaluate. Simplify and then evaluate. This is one you might want to highlight so that you're knowing the difference between these two processes, because part B is going to be evaluate and then simplify. So simplify and then evaluate says forget about the fact that we have these variables at all. Pretend like they're not even there. Like put your finger or put a sticky note over that and just like pretend we have this expression, and I say simplify that as much as possible. That's the simplify. The evaluate says sub those values in. Take these values and plug them in for those variables. So let's simplify first. So we're going to take that 24 x to the 8th y squared, and I'm going to put it over. I'm going to go ahead and distribute this 2 in right here. So now I'm going to get 2 squared x to the 6th y squared, because I just distributed that exponent of 2 in. All right, let me do some simplifying, some more simplifying. This 2 squared is going to give me 4. 24 over 4 is going to give me 6, right? So I'm going to make that a 1. That becomes a 6. And then I'm going to take off, like you're asking yourself, how can I simplify the x's and the y's? Let's take these 6 off the denominator. And the y squared over y squared, what does that equal again? It equals 1. The same number over the same number. Y squared over y squared, that's going to equal 1. So those cross off. So what am I left with? What am I left with in the numerator? I'm left with 6x squared. What am I left with in the denominator? 1 times 1 times 1. That's 6x squared over 1, which is just 6x squared. So here's your simplified expression. That's so much easier than this one, right? Now I'm going to evaluate. So this is the simplify. And now evaluate. So now I'm going to take this x equals 3 and plug it in. There is no y, so I have no y to plug in. So I'm going to do 6 times 3 squared. And that's going to give me 6 times 9, which is 54. And that's your answer. So now our part B, we should get the exact same answer, right? So if we do everything right, we should get the exact same answer. So part B says evaluate and then simplify. So again, knowing the difference between these directions, which process to use. All right, so here we go again. I'm just going to start up with this expression, but I'm going to go ahead and plug in the 3 and the -2 for the x and the y. So it's going to be 24 times 3 to the 8th times -2 squared all over quantity 2 times 3 cubed times -2. And I'm squaring that entire quantity. So now it becomes a little bit of a calculator exercise. So let's go through and let's find out what 3 to the 8th is, and then we're going to simplify 3 to the 3rd, and we're going to do some of those steps. So 3 to the 8th is 6,561. At least that's what my calculator said. You should always check me because it's possible I punch things in wrong. 24 times 6,561. The quantity of -2 squared should give us a +4 all over. We're getting 2 times 3 cubed. 3 times 3 is 9, times 3 is 27, times the -2, and then we're squaring that entire value. So in my numerator, I'm going to do another step here. In my numerator, I'm going to figure out what 24 times the 6,561 times 4 is. So 6,561 times 4 times 24 is giving me a large number. I'm getting 629,856. And then for my denominator, I'm going to figure out 27, essentially 27 times -4, right? So 27 times -4 is going to give me 108, and it should be -108, and then I'm squaring it. So then you're squaring it, which gives me 629,856 divided by 11,664. Oh my goodness. I got to plug this back in. 629,856 divided by 11,664. And I'm getting, guess what? 54. The same exact thing as we should get. So which one was easier for you? Which one did you like? Did you like simplifying and then evaluating? Or did you like evaluating and then simplifying? Me personally, I like part A. I thought that one was much easier, but you might do better with plugging the numbers in, and that might be easier for you. So I encourage you to kind of, unless the directions tell you to do both, like pick which one is most comfortable for you, whichever one you think you're going to get the correct answer for a higher probability of time, and do it that way. There are some times that you just have to be careful about about simplifying first, because you have to be careful that you're not just like automatically taking a 0 out of the denominator if you're having to evaluate at 0. Often in this class, we don't have to deal with that situation very much, which is great. So anyway, that is it for this video. If you guys have any follow-up questions, please reach out and let me know. Thanks. Bye.